Hello everyone, and welcome to section 6.6, which is on rational exponents. Remember, rational means fractional, so we won't necessarily see whole number exponents anymore. We might see 3/2, we might see -1/2. So let's take a look at what these rational exponents mean for me. So if I have a to the m over n, I can rewrite that in one of two different ways. I can rewrite that as break apart my fraction. I have 1 to the a over n to the m, and then I can translate my 1 over n to my root n to the nth power. Real person translation, your numerator tells you your power. Your denominator tells you your root. If it's a 2, it's a square root. If it's a 3, it's a cubed root. So for example, if I had 7 to the 2/3, that's my power, that's my root. So I have 7 squared, and I'm taking it to the third root. Only thing that's different, if we have a negative, that all just goes to the denominator. And you just have to make sure that your radicand is not equal to 0, so that way we don't have division by 0. If you're doing this with numbers, it's typically easier to take the root than take it to the power, because it's going to make a lot more sense to make it smaller before you make it bigger. Particularly if you're doing it without a calculator, since it's a lot nicer to make something simpler before you make it more complicated. So it is a good skill to have, to be able to write between radical form and exponential form, and we are going to see this a lot next chapter too, between logarithmic form and exponential form. So let's just take a look. It's really not as bad as you may think it might sound. So I see this in the exponent form. I have a to the 1/7, and I wanted to write it in the radical form. So I look at, this is my power, that's my root. So I have a to the first, or just a, and then my root index is 7. That's it. To do the reverse, I'm looking, okay, what is my power? I see my base is x, my power is to the first, my index is to the 5th. So let's look at this with numbers. I'm personally going to rewrite them into radical form because I find it easier to visualize. If you can see it right here, go for it. So I'm going to rewrite this. So I have 32. I'm going to have my answer squared, since I personally like to make my numbers smaller before I make them bigger, particularly if I'm doing it without a calculator. And I'm doing it to the 5th root. So 5th root of 32 gives me 2. So I'm going to do 2 squared, which is just 4. Now, I don't know about you, but personally I found that a whole lot easier than if I tried to square 32 and then figure out what the 5th root of that would be. Maybe a personal preference, but I'm pretty sure you'll all agree that that was probably easier. Let's take a look at the next one. So I do have that negative exponent, so whatever I'm working with is going to be in my denominator. So I have 25 to the first power, and then my index is 2, so it's a simple square root. 1 over the square root of 25. There's nothing out in front that tells me I might want a negative, since remember that negative in the exponent just tells me that it's going to go in the denominator. And the square root of 25 is, of course, 5. Now if there was a number out here, probably, hopefully with a parenthesis to make sure that you know exactly what you are taking the root of, if it's the positive versus the negative. That would tell you if I wanted a negative 1/5. This exponent does not tell me my answer is negative. It just tells me that whatever I get for this, I need to put it in the denominator. I can simplify rational exponents with common bases. So these both have the same base of y. So common base, we're multiplying, so I'm adding my exponents. So I have y to the 1/7 plus 4/7. Adding my fractions, 1 plus 4 is 5. So I have y to the 5/7, or if I choose to rewrite it into the rational form, I'm going to go to the power of 5, index of 7. Either of those is okay with me. Let's take a look at the next one. Again, I have that negative exponent, which tells me that whatever I'm going to get is going to go to my denominator. So I have x to the second power, and I have the cubed root of it. Well, I can't leave radicals in my denominator, so I know I'm going to have to simplify that. This is one of those cases where I have to figure out what I want to multiply by to actually get the denominator to simplify. So I'm looking, I want to get up to a power of 3, or a multiple of a power of 3, and then I have a 2. If I multiply by the cubed root of just x, x times x squared gets me x to the third. That'll help me out. 1 times the cubed root of x is just the cubed root of x, over cubed root of x squared times x is just x to the third. Cubed root of x stays in my numerator since I can't simplify that, but that cubed root of x to the third is just x. Don't have to worry about any sort of absolute value bars here since my index was odd already. And that's it. Now, there is this rule that we have that when we simplify radicals, we want to make sure that we are using the smallest index possible. So though I'm looking at this, they have different indices. Can't take the sixth root of 16. It doesn't have any perfect sixths inside of it. I can't take the cubed root of 2. Doesn't have any perfect cubes inside of it. But I'm looking at that, and I know that 16 is a power of 2. So, let's maybe rewrite it. I know I can't leave that cubed root of 2 in my denominator, but if I multiply by too many things, I'm just going to overcomplicate this thing. So let's see what we can do with this. So, 16, I can rewrite as 2 to the 4th. It's not a perfect sixth, but it is a perfect fourth. So 2 to the 4th is to the 1/6 power. If I rewrite this guy as an exponent, that's 2 to the 1/3. Now I've got a common base. If I have 2 to the 4th to the 1/6, remember we've got to multiply those if we have an exponent to an exponent. So I've got 2 to the 2/3, since 4/6 simplifies to 2/3, over 2 to the 1/3. Common base still. Subtract my exponents. 2/3 times 1/3 is 2 to the 1/3. Or, if you wish, you can write that as cubed root of 2. This is much simpler than my original. And again, because I was looking at those and I'm like, you know, I feel like there's something I can do. I wouldn't be given a problem if there's absolutely nothing I can do. Typically, at least. Let's take a look at this next one. So, there are no perfect sixths within 4 or x to the 4th. But again, maybe if we rewrite it, I know this is 2 squared, I know this is x squared, squared. Maybe we can rewrite this to at least have a smaller index. So, I'm going to rewrite this as 4x to the 4th to the 1/6. Rewrite each of these as squareds. Maybe we can simplify this to a cubed root instead of a 6th root. So I've got 2 squared, x squared, squared, all to the 1/6. I have a product with an exponent, therefore I can simply distribute my exponent. So I have 2 to the 2/6, or 1/3. If I look at my x squared to the 1/6, and I multiply all those guys, that'll simplify to x to the 2/3. Both of these guys now both have a denominator of 3, which is smaller than 6. So I can rewrite this as a cubed root. 2 is to the first power, x is to the second power. We'll look at more of these guys in class, but overall, your general rules when you're simplifying these rational exponents, you want to make sure that you have no negative exponents, just as always. No exponents in your denominator are anything other than positive integers, so we don't want those fractions that mean that we have radicals. We don't have a complex fraction, there are no fractions within our fraction, and the index of the remaining radical is the least possible number. And again, we'll practice with more of these guys in class. Until then, have a great day.